just type in classic machine learning datasets. And then this one, the Swedish auto insurance dataset, and just click download. And then we should copy these, open the notepad, paste it. But we have to fix is that here we have the comma, but it should be a dot, and then this blanket should be blank should be a comma. So edit, replace. First we'll replace comma into a dot. So yeah. And then replace the blank, the space to a comma. Okay, so we can save it. Here, I'll just call it data1. So now we can start just typing octave. And then the first thing you have to do is change the directory. Since this is where I put my data, so this folder is gonna be my directory. So just copy the path and then paste it here. But we have to change this. So as we can see here, now it's in the right place. So just click editor and then new function. I'm just going to call it ML01. And since this is our main function, I'm just going to delete this all. So now we are good. Okay, so the first thing we have to do is to load data. So data1 equals load data1.txt. And then we have to split the data into x and y. So x would be data1, and then y would be the data1, the second one. And just to make it easier, I'm going to set m equals the length of x. So it's the number of examples. So now we finished loading data. The second section is visualize the data. So the first thing I'm going to type is figure 1, since there will be 2 figures in this code. So the next is plot x, y, B stands for blue, and then O represents the circle, so it's gonna be in blue circle. And then hold on so that I can add something to this figure later. Now click save it. Yeah, you'll see it here. Now let's go to the command window and type it ML01. And this is how my figure looks like. Before I get to the third part, I'm actually going to add the bias term, so it's ones, m1, and then x. So what this is going to do is this will add a rows of 1 in front of the x. So we can set initial values. The first one is data. Data equals zeros, size x, 2, so it's the width, and then 1. I'm not putting a semicolon here because I want to see how it looks like later on. And then iteration equals 5,000. I get this number after trying out some other numbers and it worked out pretty well. Iter list is going to be zeros, iteration, 1. So what this is going to do is record my cost during the iteration. And then the last one, alpha equals to 0.001. I got this value also by trying out different one. Now after saving this, I'm going to type in this, and then it'll tell me my initial data is 0 and 0, which is what I set. Getting to the fourth one, it's perform gradient descent and cost function. So it's going to be a loop. So for I equals 1 to iteration, because we have to use the old data to train it, so old data equals data, and then data equals old data minus alpha divided by m, and then times sum x times old data minus y, and then dot times x transpose. So this is, oh no, I forgot. Yeah, so this is basically the same as the function here. And then I'm going to calculate the j, which is the cost. And the cost is going to be 1 divided by 2 divided by m, and then times sum x times theta minus y, and then dot square. So to record this, I'm going to type iter list of I is equal to j. Okay, so just to make sure if it works or not, I'm going to set the iteration to 2 just to see if this works normal or not. I don't know, 5 I guess. Save it and then go to the comment window. Same one. And as you can see, yeah, it's working. The j is getting smaller and smaller as each iteration. So now we're good. Yeah, back to 5,000. So the final one is to check the results. And then first I'm just going to type data. Oh, before this, remember to add a semicolon back here so that it will print out 5,000 values, and then data so that it will print out. And then the second one is I'm going to plot a line on it. So t equals 0, 1, and then 120. So what this is going to do, 120, I just use this value because it's nearly the maximum of x. And then what this is going to do is that t will be equal to 0, 1, 2, blah 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 up to 120, and then 1 is like a step. Now that's plot t comma theta 1 plus theta 2 times t. So what this does is the x would be t and then the y would be this. So I will plot the line up on here, the figure 1. Now the second thing we have to check is the iter list. So plot iter list. The first thing I'm going to do is to type in figure 2 so that I'll have a new window, and then plot iter list. So save it and see how it works. So here is my figure 2, and then here is my figure 1. So as you can see, the line is pretty much like the right one. And then the figure 2, what we see is that the cost is getting smaller and smaller, and now it's like nearly flat. So I guess it's a pretty good place to end.